Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. Welcome back again for another video of the series of lecture on the microfilter designs. Possibly this will be the last video, and after this video you will have enough knowledge on how to conduct your lab 5. So after this video I will upload lab 5 for you to conduct. If we need any more information or any knowledge more for our tests in the future, at the end of the semester, possibly we will cover it in the tutorials. So let's start. In the last video, we have learned about the low-pass filter design and the procedure and everything that we learned, that how to do it, that from the given specification we add this one, and then from the given specification we extract all the necessary informations for us, like the cutoff frequency and the insertion loss, at what frequency, what insertion loss, and then we use this equation to find out what is our order is, and then we find out from that order, we find out our order elements, and then after that we find out the values, and then it end up like this. The final values are here. Similarly, like low pass filter, we will design now a high pass filter. In this problem, it says that we have to design a maximally flat, remember again the maximally flat, high pass filter with a cutoff frequency of 2 gigahertz. As we already know that we need only one cutoff frequency for high pass and low pass. So we have our cutoff frequency here. Impedance is 50 ohm, means the R0 is 50 ohm, and at least 15 dB of insertion loss at 1 gigahertz. So we know already this how about this the significance of these values that has been given. So the FC is this one, and the F is this one. So at the insertion loss of 15 dB at 1 gigahertz, we need to design for a cutoff frequency of 2 gigahertz, which is a high pass filter design here. In the similar fashion that what we have done in low pass filter, we will try to calculate this first, and with this value, that what we have with this and this value, we will find out the order, and then we will find out with the order we will find out the element values, and from the element value we will find out the values of the lumped capacitors and inductors. So here we have 2 gigahertz for as a cutoff frequency, and as F we have 1 gigahertz because at 1 gigahertz the insertion loss has been given. The ripple is 0 because it's maximally flat again. So we know about this equation, how to solve this equation. So we put twice by F and twice by FC, and then we get minus 0.5. We cannot use minus 0.5 because the chart doesn't include any minus. So we take the positive value or the absolute value of this equation outcome. So now with this 0.5 and the given 15 dB insertion loss, we will find the order of the filter. It's kind of similar way. Actually, this is the way where we will design all the types of filter. So here we look at, this is attenuation, this is this value, which is 0.5 we have here. So 0.5, and then we have 15. So we still again see it's like more than 4, it's like 4.3 or something. As I told you already that if it's a fraction higher than any order, then you have to take the order immediately higher than that one. It means if it's 4 point something, then you cannot take 4, you have to take 5. Similarly, we are taking 5 here because the value is 4.3 something here. So we determined here already with the maximally flat, because this is a maximally flat response curves. So remember one more thing, for 0.5 dB and for 3 dB ripple, you have to go to figure 8.27. And for maximally flat, time delay filters, you have to go, I think, 8.28, I believe. There's one more time. So we have already determined that this is our order of the filter. So we go to the chart table, and from the table we find out these values, which is fifth element values. So we have G1 is equal to this, G2, G3, G4. It's kind of similar like the low pass filter. And with these values, we can consider the prototype, low pass prototype first. This is the low pass prototype. And with this low pass prototype, we need to convert it to the high pass. How? It's here. So if anything, we find out L, then it becomes a capacitor. If it's a inductor, capacitor then it is become the inductor. So if you want to convert this one to the high pass filter, this is a high pass filter prototype. So this will become the inductor. This will become the capacitor. This will become inductor, capacitor. This will become inductor, and this will become inductor. So capacitor will become inductor. And to calculate this one with the G values, because LK and CK, they are actually G, I already have told you. We can replace for L1, this is become L1, right? So for L1, we can L1, so R naught omega C G1. And then for C2, we need to use R naught omega C G2. You can find this equation in the chapter 8, 8.70a. So these two equations actually for this, to convert this one for the high pass filters. Remember, these equations are different. We have used before these equations. This equation is 8.67, which is for the low pass filter. For the high pass filter, the equations are different. So anything L you find, which is this value, you need to use this value. And for anything capacitor, which are you already converted from the prototype, you need to use this value. So again, I'm telling you, first you need to declare yourself a prototype of low pass filter for the high pass filter, but you don't need to calculate these values. From here, you need to convert according to this table. So if it's a capacitor, then it becomes an inductor. If it's an inductor, it becomes capacitor, as it was shown here. So from there, after you change capacitor to inductors and inductors to capacitor and so on and so forth, use these values, these equations with all the G values that we have calculated, all the G values. You need to find your L1, C2, L3, C4, and L5. Then this will become your low pass filter. That's what we intend to design. And later on, if you put this one in the ADS and you simulate this one, you will get the value of a response as a high pass filter. However, this is your part to do, not mine. I will give one more a small video uh, for you to learn how to put these values. Not high pass. I will put the low pass only. High pass and band pass you will have to do by yourself. So this one I will give a short video for Lev 5 also, and then you there you will learn how to do it in ADS.